So this is section 10.2. We're looking at finding arc measures. This is filmed in front of a live studio audience, third period. Okay, so we're looking at arc measures in this section. Before we look at the arc measures, we're going to look at an angle that we're going to relate it to, and that is a central angle. A central angle is an angle whose vertex is at the center of the circle. Later on this chapter, particularly section 4, we're going to look at inscribed angles, which will be a separate type. But for right now, as we make that connection to arcs, the central angle is what we're going to use. So, I have an angle here, angle ACB. And it has its vertex at the center, center C, and I could call that circle C. And then its two legs go out and meet on the circle at A and B. Now, I have a minor arc there with ACB, and we call a minor arc, it's the points on the circle that lie within the central angle. So our angle hits the circle at points A and B. The minor arc is all the points between A and B. So whenever we write this or identify it, it's going to be AB, and we put a little arc symbol above it. Now, don't put a straight line there because that would be a segment, or a chord in this case. But it's going to be an arc, so we put the curved arc above it. So that's telling us we're looking at arc AB that starts at A, ends at B. A major arc is going to be the points on the circle that don't lie within the central angle. So really I have this entire circle. The central angle takes up the minor arc A to B. The rest of it is our major arc. It starts at A, goes through D, ends at B. So we're going to call that ADB, and the arc above that one. We're not going to call it AB, because if we called it AB, then we really couldn't tell it apart from the minor arc. So when you see a major arc, it will be 3 letters. And it gives you the directions. Start at A, go to D, finish at B. Now I could have also called it BDA, would have been the same thing. You just follow the path it goes. Major arcs will be 3 letters to identify. Minor arcs will be 2 letters most of the time. There may be a case where you have to identify it a certain way, looking at combining them, but major arc will always be 3 letters. We won't identify it with 2 letters because otherwise it would be the minor arc. Last one we have there is a semicircle, and that's an arc with endpoints that are endpoints of the diameter. So if I extended this side out and made AD, I know it's a little crooked there, but let's imagine that AD is a diameter. A semicircle would be half of that circle. So maybe it's ABD, or we could call it another letter. Let's put an E out here, and AED. So it's really going to go back off of that central angle. You take the central angle, relate it to an arc, and then we're going to now look at measurements as we go through looking at the arcs. So as we measure the arcs, the measure of a minor arc is the measure of its central angle. What is the name of the central angle here? Oh, it's angle ACB. That's equal to the measure of arc AB. So, easy enough. Let's say that ACB is 50 degrees. That means that arc AB is 50 degrees also. They'll be the same when it's a central angle. If it was 70 degrees, it'd be 70. 90 degrees, it'd be 90. It's going to match up. Now, next thing we have here is the measure of the entire circle is 360 degrees. Well, let's use that idea to think about a minor arc. Well, it's 360 all the way around. If I had it at 90 degrees, a central angle, so this angle, let's say, is 90 degrees. Well, 90 degrees would equate to 1/4 of that circle. Well, 1/4 of 360 is also 90. So they match up nicely as we go. What we're not going to typically see, though, is an angle bigger than 180. Most of the time, the angles we've talked about to go up into 180. A straight angle is 180 degrees. We also can see that as a diameter. But we're going to look at between 0 and 180 for the angle. That matches up to the arc. Now, the measure of the major arc is the difference between 360 and the measure of its related minor arc. Well, like we mentioned earlier, our major arc here is ADB. So the measure of that is equal to 360 degrees minus the measure of AB. Or that major arc is equal to the whole circle minus the other part, which was AB. So it's all of this without that piece. So 360 minus 50 would give us 310 in this case. So it'd be 310 degrees for the major arc. Last one we mentioned there, the measure of a semicircle is 180 degrees. A diameter is what forms a semicircle. That's half a circle. If a full circle is 360, then half of it would be 180. Okay, so let's start applying that. Now, whenever they give you instructions here, look to the directions. Maybe they're indicating if you have a diameter, if something bisects, if something's congruent. Usually in that statement, they'll give you something that helps you out. In this case, they tell me RT is a diameter. Well, if RT is a diameter, that cuts the circle into two equal parts. So I know from R to T is 180 degrees. Then from R to T the other way, this time through S, is also 180 degrees. But we already know that's 110. It's going to make this 70. And what I can actually do here is fill in all of the values. And that's kind of a good process to go through. Yes, we have to find these certain things it's asking for. But if I take the diagram and fill in everything I know, then it's just going back and matching up the parts that I need, instead of trying to figure it out without the stuff written down. So now we can go back. We know we have 180 here, 180 here, and that breaks up to 110 and 70. So we see that RS from R to S is 110 degrees. Then from RTS, so this is the major arc that matches with it, RTS goes through T, it's going to be, well, 180 plus 70. Or, since I know I'm going all the way around, leaving out this 110, it's 360 minus 110. It's the same thing. I could add up the parts, or I could subtract away the part that it doesn't include. So, I get 250 here, 250 here. Either way, RTS is 250 degrees. Now, before we get too far ahead of ourselves, this 110 would be a minor arc. Because it's less than 180, it's less than half the circle. The 250 would be a major arc. Because it's more than 180, it's more than half the circle. And then our last one is RST. Starts at R, goes through S, ends at T. We already know that RT is a diameter, or we could just add 110 and 70. And it's 180 degrees, which means this is going to be a semicircle. So we've kind of hinted towards, as we've gone through it so far, adding these arcs or adding these angles together. And that's what our postulate is going to say next. And that's our arc addition postulate. Where the same ideas, we've had segment addition, we've had angle addition, now we can also have arc addition. This one says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Well, if we're going to add these two arcs together, first of all, we have to make sure they're next to each other. That's what the adjacent is alluding to. But we go from A to B, and then B to C. If they're next to each other, they share that point B. If I combine them, here's AB, here's BC. If I combine them, I get the measure of ABC. So I can add them up. Not a concept that seems too difficult. It's something we kind of already did as we started working through them, but again, it's something we have to define as we go forward. Now, we could also see here that the measure of ABC is equal to 360 minus the measure of AC, because we could always take the whole thing and subtract what we didn't use here, which would be AC. Okay, so let's look at some more examples of it. Now, before I go in and start finding individual values, it's just a good practice to see what I can figure out as I go. So, if I knew this angle, I know these three, I need this last one. A couple ways we could do it. We just have to make sure we do the correct one. First of all, we know the total all the way around is 360. Add them all up, subtract from 360, that'd give us this. We could also look at our other options. Well, maybe this would be a vertical angle. It's a good thing if we get in that practice of looking for it to be a vertical angle, but this is not, because we notice from S to Q is kind of a broken line. That's not two lines intersecting, so vertical doesn't work. Now, another way that does work is we notice that TR is a diameter. So 180 is this whole thing. We subtract off the 80, this is 100. So now I know all the angles, I can match it up with its arcs. Now I know all the information, and now it's just identifying which ones I need as I go. So we start with TQ, T to Q, it's 120 degrees. That's less than 180, so that's a minor arc. QRT starts at Q, goes through R, ends at T. So I could add 60, 180. Or, since I go QR to T, I could do 360 minus 120. That's the piece not included. Either case, I get 240, and that is a major arc. TQR starts at T, goes through Q, ends at R. That one looks like a diameter with TR, so that's going to be 180, semicircle. And then we have QS, starts at Q, ends at S, that's 60 and 100, or 160. And that is a minor. Then I have TS, starts at T, ends at S. Don't get in the trick of going all the way around. It's just the direct one. 2 letters. It's going to be a minor. So, 80 degrees. And last, RST, starts at R, goes through S, ends at T, at 80 and 100. It is 180, so it is a semicircle. Okay, our last two terms we have are congruent circles and congruent arcs. And we spent a lot of time looking at congruent triangles a few chapters ago. This one's going to be a little nicer for congruent circles. Because let's say I have two circles, A and B. We have to look what are certain ways we have to measure A and B, or any circle for that matter. Well, we can find the area and the circumference, which is something we'll do later in the year. We have the diameter and the radius, and those are values we use for circumference and area. So if we just think radius, each of those circles have a radius. Let's say they have the same radius. Let's say they both have 3 inches as the radius. So the idea of having congruent circles means if I have two circles with the exact same radius, both are 3 inches, they're going to be the exact same circle. If I drew one circle with 3-inch radius and another one, I can't draw one that doesn't look like it. That's the measurement. That describes how far out we go from the center. So, if the radius is the same, then they're congruent circles. So we can even write that. Circle A is congruent to circle B if the radius of A is equal to the radius of B. Say circle A and circle B. Okay, then we go to congruent arcs. Arcs that are going to have the same measure, kind of like congruent angles have the same angle measurement. Same idea here. So, two arcs with the same measure and either on the same circle or congruent circles. So let's say I first have this angle ABC here. There's an arc that matches up to it, AC. To have a copy of that arc, an arc that is congruent to it, it either needs to have the same measure, which I could almost draw one over here that would also have the same. Maybe they're both 120 degrees. Well, then they'd be the same. So in the same circle, that would work. But if it's in different circles, they have to be congruent circles, which we just mentioned. So let's say over here we have DEF. And DEF has its own arc, DF. Now for those to be the same, they have to have the same measure. Let's pick a number and say they're each 120 degrees. And they have to be in congruent circles. Well, congruent circles means the radiuses are the same. So, let's say they're both the same and they have the same arc, then they're going to be the same arc. Now, the opposite way to think of it. Let's say you have a circle and there's an arc there that's 90 degrees. But the radius is really small. It's 1. And then you have a bigger circle. And there's an arc there that's 90 degrees. But now the radius is 5. Those two arcs, even though they may have the same measurement, are not exact copies of another. And that's really what congruent's talking about. It's an exact copy. This one, yeah, it's 90 degrees, but it's fairly small. A lot smaller than the one that's 90 degrees up here. The same measure, but they're not the exact copy. They're not going to be congruent arcs. So, the radiuses have to be the same, and they have to have the same angle. So, let's finish up with a couple more practice problems that really look at finding the arcs when we're given that diagram. And again, fill in the information you know. Fill it in and then mark what you have, and then you can match up your values. Look for if they tell you you have diameters. And in the second one I have bisects. They give me a value and a diameter. So those are all things I want to make sure I mark because they're going to help me find the correct angle values.